if I had my professors posting their lecture notes and videos on YouTube, I would have been so happy to watch them and understand better and get the skill. It never happened for me. So I'm hoping that you will take advantage of this. Okay, we already discussed. Let's look at a few situations. So situation 1, situation 2, and situation 3. These are sets of numbers. A pair of sets, and another pair of sets. Let's suppose I connect them like this. These are 3 different values, any values you want. Let's say I connect them like this. Any values you want. And let's suppose I connect them like this. Just 3 values in, or 2, at the most 3 in each set. Question: does this represent a function? Yes, to each x value corresponds only one y value. To each x value, only one y value. To each x value, only one y value. So this is a function. I'm going to say this now because it's very important for later. This is not just a function, but also going backwards is a function. Would you agree? So if I consider this the starting point, it goes only to one y value. If this is the x value, it goes to only to y value. And if this is the x value, it goes back to only one y value. Would you agree? This function is called one-to-one. It's not only that every x corresponds to only one y, but also every y corresponds back to only one x. Why is this so important? Why do I need to know that it's one-to-one? It's for something that we are going to look at later. Is this a function? It's not a function because I determined that at least one value of x corresponds to 2 different y values. So this is a relation, not a function. What about this one, number 3? Is this a function? To each x value corresponds only one y value. To each x value corresponds only one y value. To each x value corresponds only one y value. Is this a function? Good. It is a function. Is this function one-to-one, however? No, it is a function, but not one-to-one. Because if we want to go backwards, this will not be a function. If this is x and we want to go back to where it came from, we will not know where to go back to. So this is a function, but not one-to-one. This is a relation, and this is a function that is one-to-one. Okay, next step, I would like to identify these sets. What do you think this set is called? For all of them, including for a relation. The first set. Very good. This is a domain of the function or relation. What do you think about the second set? Yes, the second set. Second set. Range. Of course, the first set is the domain, which means values of which variable? Values of x. Awesome. And this is values of y. Perfect. Okay, so let's immediately go to some problems. And I circled the problems that are recommended by my colleagues. We can choose anything you want here, not just those. For the following exercises, use the vertical line test to determine which graph shows relations that are functions. So let's look at 43. Let's look at 43. Is this a function? Yes. By the vertical line test, this is a function. It hits the graph in only one point, and we read the y value. So I'm going to do this. For this x, which is x equals 3, it hits the graph in this point, and we will be able to read the y value as 2. Do you agree with that? Awesome. Good. What about 44? No. This is an ellipse. By the vertical line test, this is not a function. What about this? Good. What about this? Right here, I would like to identify the domain and range of this function. So let's talk about the domain for a moment before you answer. The domain is measured on the x-axis, right? We know that. So imagine that you cut it with vertical lines. Yes, 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 yes. No, it does not hit the graph. Yes, 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 yes. So what will you say about the domain of this function? Yes, Flynn?
X cannot be 0.
Yes, very good. Flynn is raising an issue, and thank you for that. When we're asked about the domain, we have to write this. Although in plain English, he was correct. Anything but 0. But when we are asked to find the domain, we have to write it out what is allowed for the function. Oh, sorry. So what is allowed for the function, bless you. Okay? Yes, you're right. You have to state that x not equals 0. But this is a restriction. But when we're asked about the domain, we have to write it out. Okay, I'll come back. I would like to determine the range of this function. When we determine the range of a function, we imagine that we cut it with horizontal lines. Yes, 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 it hits the graph. Yes, it hits the graph. Yes, yes, no. Yes, 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 yes. So what will be the range of this function? The same. Very good. Yes, the range is the same. Very good. So we know how to identify a function using those Venn diagrams, we call them, or bubbles, I like to call them. We know how to identify whether a function from a graph, whether the graph, it represents a function or a relation. But what about a problem like this? Let's say I want to look at 18. Book, page 176. And 18 has x squared plus y squared equals 9. Can anyone tell us what this is? Awesome. Great job. Great job. It's a circle with a radius and a center. Very good. Excellent. Okay, you made me very happy. Okay, let's say we don't know what it is. For a moment, we're asked, is this the equation of a function? Is this the equation of a function? And I'll say I have no idea. Well, we know the answer, right? But let's say I have no idea, but it means that I have to solve for y. Okay, so please tell me the first step towards solving this equation for y. Awesome. Y squared equals negative x squared plus 9. Great job. Not yet. It's not finished. One more step. Very good. Awesome. Great job. So then y equals, be very careful now. Say it again. First of all, that's not what I wanted to hear. I'm begging you, do not say that. We talked about it. I have to address it again. The square root of a squared plus b squared will never equal the square root of a squared plus the square root of b squared, or minus. Let me give you a numerical example. Is 4 plus 9 the square root of 4 plus the square root of 9? No, because this side is the square root of 13. And this side is 2 plus 3. The square root of 13 cannot equal 5. So please remember, you can never split. We discussed that in the equation of the circle, remember? I asked you. So we had x plus h squared plus y plus minus x minus h squared plus y minus k squared equals the radius squared. And I said, okay, I'm going to take the square root. Can I simplify it? And at that time, everyone said no. But now I'm not sure why you got confused, and you said yes. So please remember that. That's not allowed. Okay. What is allowed, however, yes, Ryan, just one second. What is allowed is this, the square root of a times the square root of b, or the ratio. This is allowed. Even that under certain conditions, if they are real numbers. Otherwise, if this is not a real number, you cannot do this. If this is not a real number, you cannot split it up. So even those under certain conditions, right? So we cannot do that. Yes, Ryan, you had to say something?
You got it. Is it plus or minus the square?
Thank you. Very good. That's all I wanted. So what does this mean is, let's say for x equals 0, how many different y values do you get? And they are? Very good. So now we draw a conclusion about this equation. X squared plus y squared equals 9. We already knew the answer from the very beginning because we correctly identified it as being a circle. But now I can answer the question. Is this a function? No, because I don't need to prove anything else. If I prove that for one number I get 2 different y values, that's sufficient. It's not a function. So, which we knew from the very beginning. Not a function. Very good. Any questions so far? Okay, so here's an example. You will be very happy to see it. I know that. It's right here. For the following exercises, evaluate the function f at the indicated values. We've seen this before? Of course we have. So we're asked, first of all, to simplify that fully. Not just plug in, because everyone can plug in. So let's do that. So this is problem 31 on page 176. And the function is f of x equals the absolute value of x minus 1 minus the absolute value of x plus 1. So now I want to show you why, and I have to tell my colleagues, I couldn't have waited for the supplement absolute value till transformations when I actually needed in 3.1. So that's the reason why I couldn't wait for this. I needed it. Because otherwise we would have not been able to simplify this function now. Very good. So where do we start? Quickly. The absolute value of x minus 1, what will you dictate or say? Minus 1 for x minus 1 greater than or equal to 0. Or the opposite, for x minus 1 less than 0. Which means x minus 1 for x greater than or equal to 1, negative x plus 1 for less than 1. We will repeat for x plus 1. Can anyone get us started on x plus 1? Very good. For x plus 1 greater than or equal to 0, or negative x minus 1 for x plus 1 less than 0. Which means x plus 1, x greater than negative 1, negative x minus 1 for less than negative 1. So this was the whole thing. And now we put in the table to summarize and get the answers. And we know how many answers we will get. How many?
3.
Perfect. Well done. Thank you. It makes me very proud to hear you answer. Very proud. So the absolute value of x minus 1 and x plus 1. I'm not of a cheerleader or pumping up, but I'm genuine. I genuinely care about what you do in my class and how you perform. I'm not very good at pep talks. Okay, so we have negative infinity to infinity. Please tell me the key numbers that have to be in the table. Right? Carefully in the correct order. Perfect. Okay, so let's read. The absolute value of x minus 1 can be replaced by x minus 1 for numbers greater than or equal to 1. How many intervals we see greater than or equal to 1? 1. So I have x minus 1. It can be replaced by negative x plus 1 to the left-hand side of 1. How many intervals we have to the left-hand side of 1?
2.
So I'm going to write negative x plus 1 and negative x plus 1. You understand why I need it twice, because they're two separate intervals. That's all. We do the same with x plus 1. X plus 1 in absolute value can be replaced by x plus 1 for the right-hand side of negative 1. How many intervals we have to the right-hand side of negative 1? So I have to write x plus 1 twice. And it can be replaced by negative x minus 1 to the left-hand side of negative 1, which means how many intervals?
1.
Yes. Remember, we are subtracting these two. So I have negative x plus 1 plus x plus 1. Negative x plus 1 minus x minus 1. And x minus 1 minus x minus 1. Please combine like terms on the first one and tell me what to write. Very good, awesome. In the middle. Awesome. And the right last one. So then the absolute value of x minus 1 minus the absolute value of x plus 1 has three possibilities, 2, negative 2x, and negative 2. And now we have to choose. Remember, for each number, you can put one equal symbol. It doesn't matter if it's in the prior interval or following interval, preceding, or it doesn't matter. So, for x, very good. You want to choose that. Perfect. So then you have to use this. So what do you want on this side? Well, I want less than or equal to. Very good. And then obviously the last one is decided already. So finally we're ready to answer the question. This was only the simplification of that function. And now we're asked, yes, please,
In
Connor?
the middle column,
Yes.
is it plus 2, or is that just a sign error? We have x, negative x, and positive x, and we have positive plus 1 plus 1.
So it's negative x minus x, which is negative 2x. And positive 1 with negative 1 go away.
Oh, I forgot to distribute.
Yeah, we have to distribute this negative sign to the second one. So that's why I copied the first and I distributed a negative sign to these two. I copied the first and I distributed a negative sign to this last two. And the same thing here. I'd rather go back and check. Maybe you see something and it's an error. So I'd rather go back and check. So x minus 1 and then minus x minus 1. Is that okay? Okay, perfect. So now we can finally answer the question. The question was asking us to find all these values. So I'm reading them to you and you'll tell me what you want. F of negative 3, f of 2, f of negative a, negative f of a, and f of a plus h. Which ones? Okay, so f of negative 3. F of negative 3, yes. Any questions? Go ahead. Do I have to break that circle? No. Okay, we are doing okay. Good. Good. Okay, so f of negative 3. How much? Very good, awesome. F of 2. Very good, awesome, great job. F of negative a. Very good, so let's discuss this. In my opinion, this question should not be here, but let's discuss it since it is. If I have this function, what does this tell you? What does the model represent? What does it tell us? It says this, f of whatever equals whatever squared minus 3 times whatever and plus 4. So I can replace the whatever by whatever I want. So for example, I want to replace it by a plus h. Or maybe I want to replace it by negative a. So that would be f of negative a equals negative a squared minus 3 times negative a plus 4. As long as we understand what the function is telling us, you can ask me to evaluate for anything I want or you want. Obviously, for this particular function, there is only one x. So if we call this whole thing f of x, and we can, of course, if that's what the book is calling it, then in our situation, f of negative a will simply be 2 for x less than or equal to negative 1, 2a for x between negative 1 and 1, and negative 2 for x greater than 1. This is a very unusual situation. We normally don't evaluate piecewise defined functions like that. Yes?
When you don't switch the x on the other side of the x, why don't you do like a is less than equal to negative 1? So like negative 1 is.
That's a very good point. Yes. I agree. Since I replaced x by a, I should do it all the way. Completely agree. Thank you. I agree. However, x was replaced by negative a, so I have to be very careful here. Okay? So x was replaced by negative a, so I have to replace it everywhere. That's why you're right in a way, because I shouldn't have a and x in the same problem. But then I have to make adjustments. So f of negative a is 2, and then I have to change this into a greater than or equal to 1. Then it's 2a, and I multiply both sides by negative 1. Negative 1 less than or equal to a less than 1. I hear you talk, so I can't. It bothers me. I'm sorry. I'm sorry. I know, but you have to let her watch this. And we can sit down at the end and talk about it. I'm so sorry. My apologies. And then negative 2 for a greater than negative 1. I'm sorry, less than negative 1. It's very unusual. I would never put a problem like this. It makes no sense, really, for evaluating a piecewise function like that. It really is not necessary. Any questions? Yes.
Just real quick. 2a,
Yes.
if negative 1 is less than or equal to a, would that actually, the sign be flipped? Would the inequality sign
Every
be
time we
flipped?
multiply or divide by a negative number, we have no choice. So I cannot just leave negative a less than or equal to negative 1. I have to multiply both sides by negative 1.
I'll say the second one. If it's fine.
Even the second one, all of them have to change. So this becomes negative 1, this is right here, and this is right here. Everything flips. Is that clear?
Okay.
So negative 1 less than negative a less than or equal to 1. We multiply by negative 1. This is negative 1, this is a, and this is 1. And I have to switch everything. That's why negative 1 is here, a is in the middle, and 1 is on this side. Yeah, it's, again, not something that I would ever ask you to do. Because it's not really needed. You would never see this before. Okay. Now, something like this is extremely useful. And in the next section, I will explain what this means. So we're given a function, and this is very useful. So problem 33 on page 176. And that is giving us a function g of x, which is x squared plus 2x. And we're asked to find g of x minus g of a divided by x minus a. And of course, x cannot equal a. This is a useful situation. This is what I'm doing with my calculus class right now. In this chapter that I worked with. Okay? And I'll explain in the next section what this means. So for now, we are only asked to create this ratio. Yes, any questions? Yes, Caleb, go ahead.
Well, just thinking forward to what comes next, isn't that the definition of a limit?
With a limit in front is a definition of the derivative. So if I put the limit in front, that will be f prime of a, or g prime of a. So the limit as x approaches a, this will be g prime of a. But we don't need this for this class.
I'm just curious.
Yes, you're right. You're right. That's why this is so important. That's why this is so important. Okay, perfect. So right now we're asked to, yes, Ryan, go ahead. Yes, go ahead. Okay, so please only talk to me, please. Please. Okay, in the future. Good. So we're asked to create this ratio, put it all together, and then simplify it fully. No problem. G of x is very clear. I just copy x squared plus 2x. G of a is very clear, but please remember you either put parentheses or you distribute automatically, -1. It's up to you. I accept both methods. So what goes in parentheses?
A squared plus 2x.
Very good. A squared plus 2a. Awesome. Great job. And now, can anyone tell us what to do next? So we have x squared plus 2x minus a squared minus 2a divided by x minus a. What type of expression is this at the top? It is a polynomial. How many terms does it have? How many terms does it have? Very good, Flynn. It has 4 terms. I count 4 terms. What do we normally do with 4 terms? Very good. We factor by grouping. So let's do that. I have to decide whether to factor out from these 2, or maybe from these 2, or maybe from these 2. Maybe I should group the first 2 and the last 2, or maybe I should group the first with the third and the second with the fourth, so that I can continue. See, I have a problem. If I group these 2, I pull out an x and I get x plus 2, but this one will not come up with an x plus 2 in parentheses. So it means that I have to try this option. So can anyone tell us how to factor x squared minus a squared?
X parentheses, x plus 2.
So we're talking about x squared minus a squared.
X minus a, x plus a.
Very good. X plus a, x minus a. And now we would like to group these 2 together. And what should we factor out from 2x minus 2a? I also perfect, but I also need the sign. Very good. Positive 2. What is left in parentheses? Good. Divided by x minus a. Would you ever think of simplifying this piece with this piece? Absolutely not. Awesome. Great job. So now I would like you to tell me what is the common factor at the top. Very good. What is left in brackets in this case? Plus 2. Awesome. Great job. Now, only now I'm allowed to do what? Simplify and write 1, and I get x plus a plus 2. Well done. So keep this in mind because we're going to come back to it. I want us to look at a graph and make sure that we can evaluate from the graph and find different things that we are asked to find. So right here, 53. In 53, we are asked, given the following graph, evaluate f of 0. What does f of 0 mean, first of all? Correct. And in other words, awesome. I couldn't have said it better. But we could also call it the excellent. Thank you very much. Very good. So f of 0 is the y-intercept. And also x is 0 means f of 0 is whatever. So both. So if we're asked to find f of 0, we are told x is 0, find y. That means also the y-intercept. Very good. Well done. Thank you. So can anyone tell us what is f of 0 here? Yes, I completely agree. I draw or imagine that I draw x equals 0, which is a vertical line. It crosses the graph at 1, so I will say 0, comma 1. Solve the equation f of x equals negative 3. What does that mean? And what am I given? What am I asked to do? I'm asked to determine x when y is negative 3. Awesome, great job. So 1, 2, 3, I see or I draw or imagine that I draw y equals negative 3. I see it crosses the graph or touches the graph in this point as well as this point, and I will be reading the x values. So the x value for the positive side is 2, and on the negative side is negative 2. Very good. Are we comfortable with this kind of problem? Yes, everyone? Awesome, great job. Okay, so then for f of x equals negative 3, we found, and the problem was 53 on page 178. We found that x equals 2 and x equals negative 2. You can present them as ordered pairs, 2 comma negative 3 and negative 2 comma negative 3. That's perfect as well. You also gave me for this problem, you said 0 comma 1. It's the y-intercept. Very good. Okay. For the following exercises, determine if the relation represented in a table form represents y as a function of x. So let's look at 65. For x equals 5, there is y equals 3. For x equals 10, y equals 8. For x equals 10, y equals 14. Does number 65 represent a function?
No.
No, because we found 10 corresponding to 8 and 14. So in 65, that is a relation. So from the table, 65 on page 178, relation. Why? Because x equals 10 corresponds to two different y values, 8 equals y and y equals 14. Here is another exercise that I would like you to pick any graph from here, and I would like us to discuss whether these functions are one-to-one. Okay, we want to look at 56. First of all, is this a function? By the vertical line test, this is a function. How do we determine whether this is one-to-one? Remember, for each y, only one x. With a horizontal line test. So when I cut this graph with a horizontal line, I see I will be reading two different x values. One which is a 2 and the other one negative 0.8. So is this function a one-to-one function? No. By the horizontal line test, this is not a one-to-one function. It is a function by the vertical line test, but it's not a one-to-one function by the horizontal line test. Very good. I would like to we are given, so this is something that just caught my eye and it is recommended. So let's choose from here any of these functions, either f, g, or h, and determine or evaluate this. I mean, actually, there's both functions in there. I'm sorry, f and g are in there. Just choose. They said 75, but we can choose anything. 75? Yes?
Yes.
Okay, so let's work on 75 on page 179. And we are given, since it's f and h, I'm going to copy just f and h. I just said. So negative 2x squared plus 3x minus 1.
G minus H.
No, I just want to erase it, but I'm looking for my white out and it has grown legs. Oh, it just came back from a trip or something. Sorry about that, my apologies. Okay, so here is what they are asking us to do. They're asking us to find f of 7/3 minus h of -2. And we reviewed how to evaluate these functions, right? So f of 7/3, we can find it on the side, or we can just write 3 times 7/3 minus 2. Don't forget this negative symbol here, the sign, so minus. Put parentheses so you don't forget. And -2 times -2 squared plus 3 times -2 minus 1. I'm going to change it into a bracket because it's easier to see what's happening here. By the order of operations, we will do what first? Exponents, right? And this is basically, there is no operation here, just -2. I have to put in parentheses because there is a multiplication symbol here. So I'm going to say powers. The outside I can simplify. Nobody will stand in the way of that, right? And then I have 7 minus 2, which is 5, minus. I have -2 multiplied by 4. I can multiply, I can perform the product, -6 and -1. This is a good review type of exercise in arithmetic, right? Because really has nothing to do with other than just simple plain arithmetic. So this is 5 minus. We have to perform the product now, which is -8, and -6 minus 1, I can do that. This is -15 with minus in front, so this is 5 plus 15, and it gives us a 20. Any questions for me? Any questions? Any questions? Because I would like to move on to the next section. Before we look at graphs, before we graph specific functions, I would like to list, maybe there is in the book, and I wanted to show you. It's a good list. I look at it. On page, I just want to show you the page. I would like to go over these functions. I just don't want to tell you, go to page 174 and page 175 and study those. So if you like, if you remember these functions, I'm fine. We don't have to go over them. So this is a linear function, but a constant. This is the simplest possible linear function, which is f of x equals x. This one is the simplest possible absolute value function, which is a v function. This is the simplest possible quadratic, simple possible cubic, simple possible rational function, which I don't think you've seen before, because I don't think there was a need till today, till this class. 1 over x squared, we really don't really emphasize this that much, because we know the graph of this, and when we square top and bottom, all it happens, everything that happens is just this, moves up. Yes, this is a very important basic function. We need that. And yes, this is a very important basic function. Just this one, I wouldn't really spend too much time on it, but all the other ones are very important. So we can go over those step by step if you would like that. I don't know if you remember these functions. Do we remember these functions? All of them? Yes?
Maybe not square root.
I'm sorry?
Maybe not square root.
The square root. We want to look at the square root? Okay, very good. So let's look at the square root. So this is the simplest square root function. It does not have any transformations in it. It's not stretched. It's not shifted. No reflections, nothing. Just plain square root. Let's find the domain first. Every time we are asked to graph a function, we always have to find its domain. So what will you say about this function? Yes, please, Kyle.
It would have to start at 0 because,
Absolutely.
can't be square root.
Exactly. The quantity under the square root has to be greater than or equal to 0. Thank you. So therefore, the domain is 0 to infinity. We're going to be using this table a lot, so please get used to it. Now, of course, if you prefer a vertical table, do not switch to mine. Use a vertical table. Whatever table you want to use. Okay, so let's pick some numbers to plug in. And I want to pick numbers that is easy to take the square root from. If you say 3, I know it's 1.7, but do I really want to plot 1.7? Not really. So can anyone give us few, like 2 or 3 numbers that are perfect square? Yes, Lynn?
4, 9, 16.
Very good. So 1, 4, 9. That's good enough. So let's plug in 0. What do we get? 0. Very good. Let's plug in 1. Plug in 4. And of course 3. Perfect. That's all we need. Let's graph this function. And then I'm going to ask you about the range as well after we graph it. So 0, 0, 1, 1, 2, 3, 4. So 4 is 2, and so on and so forth. Please do not graph it as a straight line. So this is f of x equals the square root of x. Can anyone identify the range of this function? Remember, we identified the range by using horizontal lines from where it hits the graph till it does not. So what will be the range of this function? 0 to infinity. Very good. So please keep that in mind. Yes?
Range and domain always the same for a square root function.
Excellent question. Excellent question. So let's take a look at this. So what did I do to the f of x? I shifted it where? Down 3. Very good. 1, 2, 3. So this goes 1, 2, 3. This goes 1, 2, 3. So here's the new graph, which is f of x, the square root of x minus 3. Can anyone give us the range? You were talking about the range or domain? I think you asked about the range, right? Perfect. Can anyone give us the range of this new function that we just created? Awesome. Great job. So the answer is no. However, if we're talking about the simple plain base function, yes. Always positive or 0, always positive 0 for the domain and range. But if we are changing anything, we are applying the shift or any other type of transformation, they may not be. Very good question. Thank you. Okay. I would like to look at piecewise defined functions now. Piecewise defined functions. Yes, let's do the cube root. Very good. Let's do the cube root before we continue with this. So in a minute we'll come back. So let's look at the cube root. What is the domain of the cube root? Right, this is a friendly function, no problems whatsoever. No restrictions on the cube root. Very nice and friendly. And please give me 3 numbers, not too big. I prefer -1, 0, and 1. And we can also use -8 and 8. So please plug in -1 and tell me the answer. Awesome. Please plug in 0 and tell me the answer. Good. Please plug in 1 and give me the answer. That's it. So let's graph the function. At 0, 0, 1, 1, -1, -1, It kind of looks like x squared, but not really. So this is f of x equals the cube root of x. Can anyone give us the range of this function? Negative infinity to infinity, indeed. Well done. Okay, so back to piecewise defined functions. What is a piecewise defined function? Defined in pieces. Is this a piecewise defined function? No, because it only has one function, one piece. Okay, I'm going back to our notes for a minute ago. Remember this function from, I don't know, 20 minutes, half an hour ago? Is this a piecewise defined function? Yes. It has how many pieces? I want to graph this one. Ready? I'm going to copy it. So f of x equals 2 for x less than or equal to negative 1. Negative 2x for negative 1, x less than or equal to 1. And negative 2 for x greater than 1. We're going to choose another in a minute. But I would like to start with this one. So it's defined in 3 pieces. Can anyone change this into an interval notation for us? Excellent. Perfect. Awesome. Thank you. What about this one? And what about this one? We agree? And you can say, why are you doing this? Because I want to identify the domain. And I need these symbols. Okay, ready? Can anyone give us a domain of this function? Look at what we have and say the domain is. We have everything to the left of negative 1 and negative 1. We have everything between negative 1 and 1 and 1. And we have everything between 1 and infinity.
So negative in nature.
Excellent, Anna. Thank you very much. Great job. Okay. So, again, back to our table. If you remember when we used that other table to simplify the function, I asked you, please give me those 2 key numbers that have to be in the table. And you said perfectly. You said negative 1 and 1. Now we're going to put 0 as well. But why negative 1 and 1? Here's what happens at negative 1. The function changes from this piece to this piece. I'm going to copy these symbols touching right under negative 1. A bracket going to the left and a parenthesis going to the right, and they're touching. In the same way, can anyone tell us what symbols to write under 1? Same thing, right? So there is a bracket facing left and a parenthesis touching the bracket facing right. I didn't do anything, I just copied these symbols, really. Okay, next step. I know it's an overkill, but please bear with me because sometimes the functions will not be presented in the correct order. For any x values between negative infinity and negative 1, which of these 3 branches will I have to use? 2. Excellent. For negative 1 to 1, which of these 3 branches will I use? Of course. And I know it's a silly question, but which will I use for this? Very good. The point I'm making with this is these 3 branches will not overlap. One piece is to the left of negative 1, another piece between negative 1 and 1, and a third piece between 1 and infinity. They will not be extended and they will not cross one another. Okay, so let's pick, because this is linear, let's pick another number like negative 2. When x is negative 2, how much is y? Please plug it in and give me the answer. But you don't have to plug it in because there is nothing where to plug it in. So what is the answer? Of course, excellent. So when x is -1, how much is y? When x is -1, how much is y? 2. Right here inside the bracket. On the other side, bless you. On the other side, when x is -1, and you should say, you are not allowed to plug in -1 in this side, correct? Because it's a parenthesis. It's a parenthesis, it's not a bracket, right? Bear with me, if you don't want to plug in -1, then you will have to plug in -0.99999999999. So it's better to plug in -1. So what do we get? Okay, right here inside the parenthesis. Please plug in 0. Please plug in 1. Right here inside of the bracket. Please plug in 1 on the other side. Again, you should say, wait a minute. And I'll say, please bear with me. In a second, you'll see what happens. -2 inside of parentheses, so I'm going to choose another point, and I still have -2. Because these numbers are the same in both cases, there will be no gap in the graph of the function. But these numbers will not be the same. We're going to look at the next example in a minute. These numbers are rarely the same. So let's graph. From left to right, please give me the first ordered pair. Excellent. The next ordered pair, -1, 2. Is it a full point or an open point? Because there is a bracket, it will be a full point, and graphing x equals 2 is just this. In the middle, -1, 2 will be the first point, but it's already full point. 0, 0, and 1, -2. Full point or open point? Yes, because it's a bracket. And here it is. That's the middle part. You cannot extend it to the left or to the right. Finally, 1, -2 starts at the same point, and 2, -2, and that will be our graph. And this is the graph of f of x. Is this function 1-to-1? By the horizontal line test, look how many y values, how many x values I have for y equals 2. Infinite. Not 1-to-1. You will see later why this is so important. Any questions? Any questions? I would like us to choose a problem to graph from your book. I'll let you choose in just 1 second. I'm getting to it. A piecewise defined function. Please choose anything you want. For the following exercises, sketch a graph of the piecewise function. Write the domain in interval notation. And I'm going to also ask you about the range. And I also wanted to ask you about the range of this function. What about this one? Can anyone give us the range of this? Very good. Awesome. Between -2, everything, and 2. Nothing else. Great job. Thank you. Thank you. Thank you. You make my life so much easier. When my students answer their own questions or they answer my questions, I feel so great. Okay, so here we have a bunch of piecewise defined functions. Please choose the one that you feel like it, graphing. It's not going to be as easy as the previous one, I think. You choose. We want to do 41? Okay. That is an easy one. That is a very easy one, but that's okay. I'll choose the next one to make sure that we... Okay, so 41. On page 194, we are looking at f of x, which is 3 for x less than 0. and the square root of x for x greater than or equal to 0.